So we need to know and apply the basic trig identities that we have so far. And so I just wanted to review them, and then we'll see how we're going to use them, because we could use them to simplify things, or we could use them to verify identities. So first of all, let's remember the reciprocal identities. If we had secant theta, its reciprocal is 1 over, it's either sine or cosine, and it doesn't start with the same letter, so we know this one is cosine theta. And it works both ways. If you had cosine theta, that would be 1 over secant theta. Those are equivalent. The other one is cosecant theta, and that's 1 over, it doesn't start with the C, so that one's the sine theta. And again, it works also. Sine theta is equivalent 1 over cosecant theta. All right, our tangent and cotangent identities, and they are also called our quotient identities because they are a quotient, one thing divided by another. Tangent is sine theta over cosine theta, and cotangent is the reciprocal of that. They are reciprocal functions of each other. This is cosine theta over sine theta. And then our Pythagorean identities, the fundamental identity is sine squared theta plus cosine squared theta equals 1. And all of these we need to know. Often the Pythagorean identity, we might need to use this in a different form. So maybe we want it solved for sine squared theta, which would be 1 minus cosine squared theta. Or we could solve it for cosine squared theta, which would be 1 minus sine squared theta. Now the other Pythagorean identities come from this one, so you can memorize them all, or you can memorize this one and then know how to get the others if you need them. So I'm going to write down the fundamental identity again, sine squared theta plus cosine squared theta equals 1. And the way you can get the others is you can divide everything either by sine squared or cosine squared, depending on what you want. I'm going to divide all of these terms by sine squared theta to get the first one. So, whoops, I don't want the plus. I'm just dividing everything by sine squared theta and sine squared theta. And then I'm going to simplify. And so sine squared over sine squared is 1 plus, okay, this one is a cotangent, sorry, it is a cotangent. I was going to say it's a cosine over a sine, which is cotangent. So this is going to be cotangent squared theta. And then 1 over sine, well, 1 over sine, we have it here as cosecant, but it needs a squared on it, so cosecant squared theta. So that's one of the other identities. And then the other one can be found by dividing everything by cosine. I don't have enough room on the slide, so I'm going to erase, and we're going to do it over here on the right. So I'm going to divide everything by cosine squared theta to get the last one. So divide by cosine squared, divide by cosine squared, and then simplify. Sine over cosine is tangent, and it's got a squared on it, so that's tangent squared theta plus cosine squared over cosine squared is 1, and 1 over cosine squared theta, well, that is secant squared theta. So there's our other Pythagorean identities down here on the bottom, and then you could solve them for one of the other terms if you needed to, depending on how you wanted to use it. So let's see a couple examples where we now simplify. So here's the first one. I have a sine x and a cotangent x, and I'm just trying to use identities to simplify. So I'm going to rewrite the tangent in terms of its sines and cosines, not the cotangent. So cotangent is cosine x over sine x, and then I can see that the sine x's would cancel, and so my simplified version is cosine x. Let's look at another example. So here I see I have 1 minus cotangent squared theta sine squared theta. So I'm thinking I'm going to use the cotangent again and use its identity and write it in terms of sines and cosines and see what I have. So I have 1 minus cosine squared theta over sine squared theta. That was cotangent squared, and then I still have that sine squared theta. Now that helped me because I can reduce these guys and cross out the sine squareds. I have 1 minus cosine squared theta, but I want to write that to be simple. The less amount of terms, and if we can write it without fractions, those are considered more simplified. So what is 1 minus cosine squared theta? Well, in that Pythagorean identity we had as solved for sine squared, that is sine squared theta. So I've simplified that down to sine squared theta.